All right, so we're just starting this unit. We're looking at number theory, and the first thing you guys should know from way back from our first unit is natural numbers. So natural numbers is the set of counting numbers that are greater than 0, and it's usually represented by the letter N, as it is here, okay? Notice that there's no negatives because it's greater than 0, and they're whole numbers. Okay, normally when you count, you don't say 2 1/4, 2 3/4, so on and like that. You usually count.
Say they're whole numbers?
They're whole numbers, yep. Okay? A factor of a number is a natural number that is multiplied into another number. So for instance, if you look at 2 times 4 equals 8, then those two numbers are factors of 8. So both of them, 2 and 4, are factors of 8. Now, you guys are probably familiar with both of those vocab terms, but the big thing here is that I find that people have a hard time with are these ones, the divisor and the divisible. And instead of actually giving you a definition of those, I felt like if I give you an example, it would make more sense. So please write these 3 down, because as you're going to do your homework, and if Blitzer uses any of these, you'll be able to refer to this little example right here. So 24 is divisible by 8. So that's using the word divisible. But if you use the word divisor, you're going to write what you're dividing by first. So 8 is a divisor of 24. You could also say 8 divides 24. A prime number is a natural number that's greater than 1 that has only itself and 1 as a factor. So an example of that would be 7. And the only prime number that's even in existence is the number 2. All other even numbers are not prime. Okay? But a composite number is a natural number greater than 1 that is divisible by another number. So an example of that would be, say, 12. Okay? 15. 9. Just because it's odd doesn't mean that it's prime. Some people mistake that because 3 times 3 is 9, right?
Yeah.
Yeah.
So that's easy.
So the basic rule here is if it's divisible by 2, then it has to be an even number. Does that make sense?
Yeah.
Yeah. So this one has a 5 on the end. It's not even, so it's not divisible by 2. But this one is. Okay? So 2s are pretty easy to figure out. If it's divisible by 3, what you're going to do is add up all the digits together and see if that's divisible by 3. So for this number, 7245, 7 plus 2 is 9, 4 plus 5 is 9, and 9 and 9 is 18, right? Is 18 divisible by 3? Yes, so that's why it's a yes. Okay? We would do the same thing for 26, 4, 28. So 26 added together is 8, plus 4 is 12, plus 2 is 14, plus 8 is 22. Basically, I'm just adding each of the digits together. Okay? Is 22 divisible by 3?
No.
No. That's why I put a no here. Yes? Oh, 2 plus 6. That's what I meant.
That's what I was confused.
Oh, sorry. 2 plus 6 plus 4 plus 2 plus 8. Yeah, is 22. All right.
Stop.
All right, so let's see if 4 is divisible. All you're going to do is take the last 2 digits. So like on 7245, all you're going to look at is the number 45.
Nope.
So that's not divisible.
Can't do it.
And then is 28 divisible by set 4?
You're darn right.
Yes, it is. So you're just looking at the last 2 digits there. All right, so for this one, for 5, in order to see if it's divisible by 5, the last digit has to be a 0 or a 5. Okay? On this one, 7,245, it ends in a 5, so yes. This one ends in an 8, so no.
Why come the test yesterday and been our missed up? There's been so much.
All right, so now if you want to look at 6, we want to see if 6 is divisible. You have to look up above and see if 2 and 3 are both factors. So if I were to go back up here, the screen,
It says no, so.
so this one says no and yes. They're not both factors, therefore this one's no. And this one says yes and then no, so once again, it's a no for 6. Yeah, so if it were like the number 12, okay? So the number 12, if you add the two digits together, it's 3. Is 3 divisible by 3? Yes. And it ends in an even number, so both 2 and 3 go into it. So yes, 12 would be divisible by 6. All right, for number 8. The number 8, you're going to look at the last 3 digits and see if they form a number divisible by 8. So going back to the top here, we're looking at 7,245. I'm only going to take this part of it and look at it. And same with this one, I'm only going to take 428 and look at that. Okay, so here I wrote it again. And what you do is you divide them by 8. You can do them in your head and see if it works out. So 24 divided by 8 is 3, no left over, but 5 is not divisible by 8, so it's a no. 42 divided by 8 is 5 with carry the 2 down, so you have 28. 28 divided by 8, nope, it's not divisible. All right? All right, so let's look at the number 9. Which one? There's 2 of them. All right, so 9, we want to see if 9 is divisible into these. And so once again, you're adding the digits together. So going back up to 7245, you add that together, you get 18. Okay, is 18 divisible by 9? Yeah, it is. So yes, it is, but is 22 divisible by 9? No. Okay? It's divisible by 10 if it ends in a 0, and neither one end in a 0. And then on 12, it's like the number 6. You have to go back up and see if 3 and 4 are both factors, and neither one of them have 3 and 4 as a factor. All right, here's something that I want you to write down because this means something totally different. Right here and here. The one with the line that's vertical between the two of them, that means 3 divides 8,142. The other one with the slanted line, that means 3 is divided by. So that's like a fraction. Make sure you know the difference between those two, because those are in your homework for tonight. All right, so we want to look at what's called the fundamental theorem of arithmetic. I know. Okay. All right. So every composite number can be expressed as a product of prime numbers in only one way. Okay, the best way I can describe this is, you guys have heard of genes and genetic code, right? DNA. Okay, every composite number has a genetic code of prime numbers. It's unique to that number. No other number has the same code. Okay, and that's basically what the fundamental theorem of arithmetic is saying. So for instance, if I take the number 12 and do a product tree with it, this would be our factor tree. It would be 3 times 4 goes into 12. and then 2 and 2 goes into 4. So my prime numbers that go into 12 are 3, 2, and 2. And I can rewrite it like this. Okay? That is also called, and that goes into the next thing, the prime factorization. Okay? So each number can be expressed as a product of its prime numbers. For example, 24, if I were to make the factor tree of this, 6 and 4 go into 24, 2 and 3 go into 6, and 2 and 2 go into 4. There are other ways I could have done this. I could have made a factor tree with 12 and 2, 4 and 3, 2 and 2. They come up with the same answer. I could do 24 by 8 and 3. They all end up with the same prime factorization. All right, so let's talk about the greatest common divisor. That is the largest common factor of a group of numbers. So if I were to actually look at 12 and 24, the largest number that goes into both is 12. What if I looked at 36 and 24? What's the largest number that goes into 36 and 24? 6? Does 8 go into 36? Yeah, it doesn't. 9? Does 9 go into 24 though? No, so I think 6 is the largest common factor. Oh, wait, no, there's a bigger number. 12. So it's not 6, it's 12. Okay, there is an easier way of figuring that out, and I'm going to show you guys how to do that in just a second. Okay, the least common multiple is the smallest common number that is in a group of numbers that multiply into. So if you take 8 and 6, I want to see what's the smallest number that they both multiply into. So this would be like saying 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and so on. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 24. So they both have 24 as the least common number they multiply into. Okay, so here's the method of finding the greatest common divisor. You guys can just write down the example if you'd like. So I have 36 and 24. What I want to do is, first of all, find their prime factorization. So I'm going to make a factor tree of 24. What goes into 24? 2 and 12. Okay, what else goes into 12? 3 and 4. And what goes into 4? 2 and 2. So its prime factorization is 2 times 2 times 2 times 3. Okay, we're going to do the same thing with 36. Okay, so what goes into 36? Okay, 6 and 6, 2 and 3, 2 and 3. So 36 prime factorization is 2 times 2 times 3 times 3. Okay, so that's the first step. The second step to finding the greatest common divisor is to circle the ones that they have in common, the pairs. Okay, there's 2 pairs of 2's and then 1 pair of 3's. So 2 times 2 times 3, that's 12. That's the greatest common divisor.
I feel like the other one's a lot easier.
This way was a lot easier?
Well, I suppose once
The other
you
way?
get a bigger number,
Yeah, the bigger numbers is where it gets tricky.
Out of 10.
So once again, let's take the number 24 and 36. We're going to be looking for least common multiple. We already found that 2 times 2 times 2 times 3 is 24. And then 2 times 2 times 3 times 3 is 36. Okay, so on this one, we want to look at which one has the greater number of 2's. 24 or 36, which one? 24, so we're going to take 3 2's. Which one has the greater number of 3's? Okay, we're going to take 2 3's. Then we multiply all that together. So we have 8 times 9, which is 72. 72 is the least common multiple of 24 and 36. All right?